Since Repair Clinic encourages you to perform this repair safely, a warning icon will appear when you should use caution. To replace the compressor in this Goodman central air condensing unit, you will need these tools. You should also wear personal protective equipment, such as safety glasses and gloves. We recommend that only licensed technicians perform this procedure. Before you begin, shut off the power to the unit. You can do this by removing the fuses from the disconnect box or switching off the circuit breaker. Shut off the power to the furnace as well. Your first step is to recover the refrigerant from the condensing unit's refrigeration system. To do this, remove the protective caps. Then thread two valve core removal tools onto the liquid and vapor service valves. With both valves on the tools open, push the stems in and rotate counterclockwise to unthread the core or Schrader valve from each service valve. Close the valves on the tools, then unthread the stem nuts to fully remove the stems and cores. Next, attach vacuum hoses to the ports on the tools. Attach the opposite end of the hoses to a T-connector. Now attach a third vacuum hose to the T-connector. Then attach the opposite end of the hose to the inlet port on a refrigerant recovery machine. Use a fourth vacuum hose to connect the outlet port of the recovery machine to a recovery tank. Set the recovery tank on a digital scale. Open the valves on the core removal tools attached to the service valves. Now partially unthread the hose attached to the inlet port on the refrigerant recovery machine for a few seconds to purge the line. Then tighten the hose. Turn on the scale and calibrate to 0. Now select Recover on the digital scale control. Open the inlet valve on the tank. With the recovery machine's inlet valve closed, open the outlet valve. Turn the machine on, then open the inlet valve to recover the refrigerant. This process will take approximately 10 to 20 minutes. The total amount of recovered refrigerant should be close to the factory charge amount indicated on the model number label attached to the condensing unit. Once the refrigerant has been fully recovered, close the valves on the tools attached to the service valves, as well as the valve on the recovery machine. With the valves closed, Turn off the recovery machine and close the inlet valve on the tank. Detach the vacuum hoses from the core removal tools. Be aware, the old refrigerant will need to be recycled in accordance with EPA regulations. Next, use a 5/16" nut driver to unthread the 2 lower screws, securing the unit's control box access cover. Loosen the 2 upper screws directly above the access cover so you can pull the cover down to remove. Use wire cutters to cut the zip tie bundling the wires together. You should release the potentially stored electrical charge in the capacitor to avoid injury by placing a flathead screwdriver across each set of terminals. Avoid touching the metal portion of the tool when doing this. Now detach the brown and purple fan motor wires from the capacitor and the black fan motor wire from the contactor. Next, using the 5/16" nut driver, fully unthread the 14 screws securing the air grill cover. With all the screws unthreaded, lift the cover off of the unit. Cut the zip ties securing the wires to the condenser coil so you can fully remove the cover to access the compressor. When replacing the compressor, we recommend installing a new filter dryer as well. For better access to this component, unthread the 2 screws securing the control box to the frame. With the screws unthreaded, pull the control box down and rotate it outward to move it out of the way. Now unthread the 4 screws securing the lower access cover. Remove the cover to reach the filter dryer. Unthread the 2 screws to release the filter dryer mounting strap. Use a tubing cutter to cut the 3/8" copper tubing at the top and bottom of the filter dryer to remove the old component. When installing a new filter dryer, first remove the protective caps. Now use a deburring tool to eliminate any burrs on the inside of the cut ends of the copper tubing. Clean and sand the ends of the tubing to remove any additional debris. Now, with the arrow on the new filter dryer label facing downward toward the surface valves, insert the refrigerant tubing into the component. Apply some cooling gel to the top and bottom of the filter dryer, to prevent the metal from overheating when brazing. Apply some cooling gel to the top and bottom of the filter dryer, to prevent the metal from overheating when brazing. Apply some cooling gel to the top and bottom of the filter dryer, as well as the liquid surface valve, to prevent the metal from overheating when brazing. Before you begin brazing, you should introduce a small amount of nitrogen into the refrigeration system using a nitrogen tank and a manifold gauge. To do this, attach the blue hose from the manifold gauge to the core removal tool threaded onto the low side vapor service valve. Attach the gauge's yellow hose to the metering device on the nitrogen tank. Open both valves on the tools attached to the high and low side service valves. Open the low side manifold gauge valve or valves, but keep the high side gauge valve closed. Now open the nitrogen tank valve and set the metering device on the tank to 5 standard cubic feet per hour. This will help prevent the inner walls of the copper tubing from oxidizing due to the heat caused by the brazing. Now use an acetylene torch and a brazing rod to seal the tubing joints. Once sealed, close the valve on the tool attached to the low side vapor service valve, as well as the low side valve or valves on the manifold gauge, and the nitrogen tank valve. You can use a wet rag to cool the tubing and wipe off the gel. Position the filter dryer behind the mounting strap and thread the 2 screws to secure the strap. To uninstall the old compressor, first disconnect the wire harness. Now use the tubing cutter to cut the 2 copper tubes attached to the compressor approximately an inch away from each port. You'll need to use a 1/2-inch socket with multiple extensions to unthread the 4 mounting bolts securing the compressor to the base of the unit. With the bolts unthreaded, you can use the claw side of a hammer to help lift the old compressor out. We recommend pinching off the tubing remnants on the old compressor and seal them by brazing, a requirement when shipping the component to the manufacturer for warranty purposes. To prepare the new compressor for installation, remove the rubber plugs from the ports. Then clean and sand the ports. Use the deburring tool to help eliminate any burrs from the copper tubing. Then clean and sand the ends of the tubing as well. Now position the new compressor on the base of the condensing unit. Thread and tighten the 4 mounting bolts. Insert the copper tubing into the ports. Apply cooling gel to the compressor near the ports. Reopen the valve on the core removal tool attached to the low-side vapor service valve, as well as the manifold gauge's low-side valve or valves, and the valve on the nitrogen tank. With the small amount of nitrogen flowing through the system, use the acetylene torch and brazing rod to seal the copper tubing to the compressor. With the compressor tubing sealed, close the valves on the tool attached to the low-side vapor service valve, the manifold gauge, and the nitrogen tank. Again, you can use a wet rag to help cool the tubing and wipe off the gel. Connect the wire harness to the new compressor. Next, you should induce pressure in the refrigeration system to check for leaks. Note the factory test pressure rating range indicated on the model number label. You'll want to induce pressure slightly above the lower parameter rating. For this unit, we're choosing 300 pounds per square inch. Confirm the low-side manifold gauge valve or valves are closed. Then close the valve on the blue hose and confirm the valve on the tool attached to the low-side service valve is closed. With both valves closed, detach the blue hose. Attach the red manifold gauge hose to the core removal tool threaded onto the high-side liquid service valve. Confirm the tool valve is open and open the hose valve. You will need to detach the nitrogen tank's metering device and reattach the yellow hose to the tank. Now open the valve on the tank and open the high side manifold gauge valve or valves to induce the designated amount of pressure. Once the pressure amount is reached, close both the manifold gauge valves and the valve on the nitrogen tank. Observe the pressure amount for approximately 20 minutes to confirm the system is not leaking pressure. You can also apply a leak detection solution to the copper tubing joints near the compressor and filter dryer to help determine if any leaks are present. Once you confirm the system is leak-free, open the valve on the tool attached to the low-side vapor service valve to release the pressure. Detach the red hose from the tool threaded onto the high-side liquid service valve. You can now reposition the lower access cover and secure it with the screws. Rotate the control box inward and push up. Rethread the two screws to secure. Set the air grill cover on the top of the unit, allowing enough space to feed the fan motor wires through the hole in the control box. Use a new zip tie to secure the wires to the condenser coil. With the wires secured, fully align the cover on the condensing unit. Thread the 14 screws to secure. Do not fully tighten the 2 screws above the control box. Attach the black fan motor wire to the contactor terminal. Attach the purple wire to the common terminal, indicated by the letter C on the capacitor, and the brown wire to the fan terminal. Use a new zip tie to bundle the wires together. Reposition the upper access cover and replace the 2 lower screws. Tighten the 2 upper air grill cover screws. Next, you will want to confirm the refrigeration system is fully evacuated before introducing new refrigerant. To do this, attach the vacuum hoses to the core removal tools threaded onto the liquid and vapor service valves. Attach a digital vacuum gauge to the port on the side of the core removal tool threaded onto the liquid service valve. Use a vacuum hose to connect the T-connector to a vacuum pump. Turn the digital vacuum gauge on and confirm both valves on the tools attached to the service valves are open. Turn on the vacuum pump to fully evacuate the refrigeration system. This will take approximately 20 minutes. It is recommended to evacuate this system to 500 microns or below. Close the valves on the 2 core removal tools attached to the service valves and turn off the vacuum pump. Now observe the vacuum gauge for approximately 10 to 15 minutes to confirm the micron level does not exceed 1000 microns. Once confirmed, detach the vacuum hoses from the core removal tools. Detach the digital vacuum gauge as well. Next, confirm the cores or Schrader valves are inserted into the ends of the core removal tool stems. Insert the stems into the tools and tighten the stem nuts. To reinstall a core, open the valve on the tool, push the stem in, and rotate clockwise to thread the core into place. Repeat for the other service valve. With the cores reinstalled, unthread both tools. You're now ready to replace the refrigerant in the system. We recommend using new refrigerant when doing this. Attach the manifold gauge's yellow hose to a refrigerant tank containing the refrigerant type indicated on the unit's model number label. Turn the tank upside down on the digital scale to ensure the liquid refrigerant will disperse through the hoses. Open the manifold gauge valves and the valve on the tank. Now open the red and blue hose valves briefly to purge the hoses. Once purged, attach the red hose to the high side liquid service valve and the blue hose to the low side vapor service valve. Close the manifold gauge valves and open the hose valves. Calibrate the scale to 0. Then set the scale for the appropriate factory charge amount as listed on the unit's model number label. This unit requires 91 ounces. Open the red high side manifold gauge valve or valves controlling the input to the liquid surface valve. Observe the scale and close the manifold gauge valve or valves once the appropriate amount of refrigerant has entered the system. Now restore power to both the condensing unit and the furnace. Lower the thermostat to call for cooling and allow the condensing unit to run for approximately 5 minutes. Depending on the type of metering device used on the furnace's evaporator coil, you will now need to check either the superheat or subcooling measurement. If the metering device is a piston or orifice style, you will check the superheat measurement. To do this, attach a temperature meter to the low side copper line connected to the vapor service valve. Note the temperature. Now observe the vapor service valve indicator dial on the manifold gauge to note the saturated temperature of the evaporator coil. The superheat measurement will be the saturated temperature of the evaporator coil subtracted from the copper line temperature. Next, use a psychrometer's wet bulb to measure the air temperature in the return duct of the furnace in the area before the air reaches the evaporator coil. Use the psychrometer's dry bulb or a regular thermometer to measure the temperature of the outside air surrounding the condensing unit. Now, using a target superheat chart, you can identify the target superheat number by noting where the two air temperature readings intersect on the chart. If the actual superheat measurement is notably higher than the target number, you will need to add refrigerant to the system until the actual superheat measurement more closely aligns with the target. If the actual superheat measurement is notably lower than the target number, you will need to recover some of the refrigerant until the two numbers more closely align. It is recommended to perform the superheat testing procedure a second time for accuracy. If the metering device on the furnace's evaporator coil is a thermal expansion valve, you will need to check the subcooling measurement. To do this, attach the temperature meter to the high side copper line connected to the liquid service valve. Note the temperature. Now observe the liquid service valve indicator dial on the manifold gauge to note the saturated temperature of the condenser coil. The subcooling measurement will be the copper line temperature subtracted from the condenser coil's saturated temperature. This measurement should be between 10 to 20 degrees Fahrenheit or within 3 degrees, plus or minus, of the designated temperature indicated on the model number label. If the subcooling measurement is notably higher, you will need to recover some of the refrigerant. If the subcooling measurement is notably lower, you will need to add some refrigerant. Once you've confirmed the refrigerant level is accurate, close the valve on the refrigerant tank and open the blue low side manifold gauge valve or valves to let the residual refrigerant enter the vapor surface valve. Close the two hose valves and quickly detach the hoses from the surface valves. Replace the protective caps on the valves. Or install locking caps if required. The central air condensing unit should now be ready for use.